Hello everyone, welcome to the lecture again. In the last two lectures, we learned about the Cartesian coordinate, planar polar coordinate, spherical coordinates. Today, we are going to study the cylindrical coordinate system. So, cylindrical coordinates. Here the axes are r, phi and z, and let me define them. So, suppose you have again the x axis, the y axis and the z axis, and there is a point P which has a coordinate of x, y and z, and its position vector is, let us say, capital R. Then in cylindrical coordinate you draw a cylinder of radius small r with a height z. Okay. So, let me draw a cylinder. Of radius small r and its height is z, and the angle that this radius vector r makes from the x axis is your phi. Okay. So, this angle is phi. Therefore, the coordinate of P in the cylindrical coordinate becomes r, phi and z. Let me repeat again, r is the radius of the cylinder, phi is the angle that this radius vector makes from the x axis, and z is the height of the cylinder. Now, from the geometry you can see the transformation equation. The transformation equations are x is equal to, the value of x will be the projection of r along the x axis. So, that is r cos phi. The value of y is r sin phi and z is z. Okay. Therefore, the vector r, which is xi plus yj plus zk, I can write down in the cylindrical coordinate system as x is equal to r cos phi I plus r sin phi j plus z is z k. Now, as we have done previously, let us look at the unit vector along the r, phi and z direction. For that, I have to differentiate this equation with respect to small r, small phi and small z. Okay. So, let us call it some equation number A and differentiate del r over del r. So, you can see it is cos phi I plus sin phi j. And what is the value of del r over del r? Magnitude is square root cos square phi plus sin square phi, which is equal to 1. Therefore, this becomes our h1. Therefore, the unit vector r cap becomes cos phi I plus sin phi j. Let us call it equation number 1. Now, let us calculate del r over del phi. So, from equation number A, you can see that del r over del phi is minus r sin phi I plus r cos phi j, which can be written as, so I can take r as a common factor. This is minus sin phi I plus cos phi j. Now, let us see what is del r over del phi. This is indeed r, because square root sin square phi plus cos square phi is equal to 1. So, therefore, this becomes your h2, and whatever is there in the bracket is your phi cap. So, this is minus sin phi I plus cos phi j. Let us call it equation number 2. Now, let us calculate del r over del z, and from equation number A, it is clear that del r over del z will be just k cap. So, del r over del z will be k cap. Therefore, del r over del z modulus will be 1, and this becomes our h3, and z cap becomes k cap. Now let us look at the differential length, differential area and differential volume in the cylindrical coordinate system. So we know the general formula, dl is h1 du1 u1 cap plus h2 du2 u2 cap plus h3 du3 u3 cap, and our u1 u2 u3 are r phi z, and h1 h2 h3 is 1 r and 1. So let us put them in this equation. So we get dl, h1 is 1, u1 is r, so dr r cap plus h2 is r, u2 is phi, so d phi phi cap plus h3 is 1, and u3 is z, so dz z cap. Therefore dl can be written as dr r cap plus r d phi phi cap plus dz z cap. This is the differential length, or you can call it the displacement dr. Now let us look at differential area. Differential area, let us say we are looking in the z direction. So it will be h1 du1, h2 du2 and then u3 cap. Okay. So h1 is 1, u1 is dr, h2 is r and d phi. So therefore it becomes r dr d phi in the z direction. Okay. Now the differential volume, in cylindrical coordinate system is again h1 h2 h3 du1 du2 du3, and the value of h1 h2 h3, let us put 1 r1 and dr d phi dz. So the volume dv becomes r dr d phi dz. Okay. Now let us find out the velocity and acceleration in this coordinate system. So you can see from the figure that vector r can be written as r r cap plus z k cap, because this r will be this r plus that r from the vector. So let us call it equation number, let us say capital A, and we can find out the velocity by differentiating this with respect to t. So let us do that. So as I said, vector r is r cap plus z k cap. This is equation number A. So velocity v is nothing but dr over dt, and it will be d by dt. Vector r is r cap plus z k cap. So let us differentiate this. So we have r cap dot plus r cap r dot, and k is constant. So therefore it will be just z dot k cap. Okay. Now as earlier we have to find out what is the derivative of r cap. Okay. So let us look at the derivative of r cap dot, this is nothing but d over dt of r cap, and r cap we have already find out from equation number A. It is cos phi I plus sin phi j. So let us look at the derivative. It will be minus sin phi phi dot I plus cos phi phi dot j, and I can take phi dot outside. So it becomes minus sin phi I plus cos phi j, and this is the value of phi cap. Let us look at equation number 2. So this becomes phi cap phi dot. Let us put this in the above equation. So we have v equal to r cap dot is phi dot phi cap plus r cap r dot plus z dot k cap, or we can write down V equal to r dot r cap plus r phi dot phi cap plus z dot k cap. This is the expression for the velocity in cylindrical coordinate system. So, r dot is the component along r direction, and similarly r phi dot is the velocity component along phi cap direction, and z dot is of course the velocity along the k direction. Now, this is your homework problem. To find out the acceleration, I am giving you the final answer. The acceleration A, let us say it is written in this form, A r r cap plus A phi phi cap plus A z z cap. Then the value of A r will be r double dot minus r phi dot square. A phi will be r phi double dot plus 2 r dot phi dot, and A z equal to z double dot. Okay. So, these are the component along the r direction. This is the component of the acceleration along the phi direction, and of course, this is the component of the acceleration along the z direction. Now, let me summarize the result that we have obtained so far. So, we studied various coordinate systems. We studied the Cartesian coordinate, planar polar coordinate, spherical coordinate, and today we studied the cylindrical coordinate. Okay. We used u1, u2, u3, h1, h2 and h3, where u1, u2, u3 are the coordinates and h1, h2 and h3 are the scale factors. So, everything can be written down in this term. For Cartesian coordinate, u1 was x, u2 was y, u3 was z, and h1, h2, h3 were 1, 1, 1. The planar polar coordinate system was defined on 2 dimension. Therefore, there was no u3, we have r and theta, and h1 and h2 were 1 and r. For a spherical coordinate system, we have r, theta and phi, and h1, h2, h3 were 1 r, r sin theta. In the cylindrical coordinate system, it was r, phi and z, and h1, h2 and h3 were 1, r and 1. Now, let us look at a very simple example, and the problem statement is following. Given point P equal to -2, 6 and 3, evaluate P in spherical and cylindrical coordinate system. So, the point is given in Cartesian coordinate. So, let me make the Cartesian coordinate x, y and z, and let us say the point P is here -2, 6 and 3. Then in a spherical coordinate system, you have the coordinates r, theta and phi. So, let us say this is r, and the angle that this r is making from the z axis is theta, and its projection that makes the angle from the x axis is phi. So, from the geometry you can see that r is square root x square plus y square plus z square, theta is tan inverse square root x square plus y square over z, and phi is tan inverse y over x. Now, since the value of x, y and z is given here, so you can put it in these equations. You will get r is equal to 7, theta is equal to 64.62 degree, and phi is equal to 108.43 degree. Therefore, in a spherical coordinate system, the coordinate of point P is 7, 64.62 and 108.43 degree. Now let us represent this point P in cylindrical coordinate system. You know, in cylindrical coordinate system the coordinates are r, phi and z, where r is the radius of the cylinder and phi is the angle that this radius vector makes from the x axis, and z is the height of the cylinder. So, you can see from the figure that rho is square root x square plus y square, phi is tan inverse y over x and z is z. Now, x, y and z is given, they are minus 2, 6 and 3, therefore, rho you can calculate, it comes out to be 6.32, phi comes out to be 108.43 degree and z is of course 3. Therefore, in cylindrical coordinate system the point P becomes 6.32, 108.43 degree and 3. Now, let us look at one more problem statement. Question number 2. Express the vector A, which is given as rz sin phi ar cap plus 3r cos phi a phi cap plus r cos phi sin phi a z cap in Cartesian coordinate. Okay. So, note that this vector is given in terms of ar, a phi and a z. Therefore, this is written in the cylindrical coordinate system. So, we have x axis, y axis and z axis, and in cylindrical coordinate you have r, which is the radius of the cylinder, its height z, and then phi is the angle that this r makes from the x axis. So, this is your phi. So, vector A is given as rz sin phi a r cap plus 3r cos phi a phi cap plus r cos phi sin phi a z cap. Now, in general, as in cylindrical coordinate a vector A is written as ar r cap plus a phi phi cap plus a z z cap, where ar is rz sin phi, a phi here is 3r cos phi and az is r cos phi sin phi. So, we know the value of r cap, phi cap and z cap in Cartesian coordinate. So, therefore, this A I can write down as ar r cap is cos phi a x cap plus sin phi a y cap plus the value of phi cap is minus sin phi a x cap plus cos phi a y cap plus a z z cap. I can collect the coefficient of a x cap, a y cap and a z cap. So, this I can write down as a x cap a r cos phi minus a phi sin phi plus a y cap a r sin phi plus a phi cos phi plus a z z cap. Now, the value of a r is already known, it is r z sin phi. Therefore, I can write it as a x cap r z sin phi and cos phi minus a phi is also known, it is 3r cos phi. So, this will be minus 3r cos phi sin phi plus ay cap r z sin square phi plus 3r cos square phi plus az is r cos phi sin phi z cap. Let us call this equation number 1. Now what I have to do is I have to write down this r, z and phi in terms of the Cartesian coordinate. So for that we have the transformation equation. The transformation equation from cylindrical to Cartesian coordinate is r equal to square root x square plus y square. This you can see from the geometry, and phi or tan phi is y over x and z remains z. So if tan phi is y over x and we need what is the value of sin phi and cos phi, so that we can find out. So sin phi will be y over square root x square plus y square, and cos phi therefore will be x over square root x square plus y square. Now all these transformation I can put in equation number 1. So let us look at the first term, the coefficient of ax cap. The coefficient of ax cap is rz sin phi cos phi minus 3r cos phi sin phi. So let us put the values. R is square root x square plus y square, z is z, and sin phi is y over square root x square plus y square, and cos phi is x over square root x square plus y square. This is rz sin phi cos phi minus 3, r is square root x square plus y square into cos phi is x over square root x square plus y square, and sin phi is y over square root x square plus y square. So this square root will get cancelled with this and this will get cancelled with that. So I can write down this as x y z minus 3xy over square root x square plus y square. This is the first term, the coefficient of ax cap. Similarly, we can find out the coefficient of ay cap, so which is rz sin square phi plus 3r cos square phi. So let us find out that. So we have rz sin square phi plus 3r cos square phi. So again r is square root x square plus y square, z is as it is, and sin square phi is y square over square root x square plus y square multiplied by square root x square plus y square. Okay. So this is your rz sin square phi plus 3, r is square root x square plus y square, and cos phi is x square over square root x square plus y square into square root x square plus y square. So again this square root will cancel with this and this will get cancelled with that. So therefore we are left with y square z over square root x square plus y square plus 3 x square. Now let us look at the coefficient of z cap, which is r cos phi sin phi. So now we are looking for r cos phi sin phi, r cos phi sin phi. So r is square root x square plus y square, cos phi is x over square root x square plus y square, and sin phi is y over square root x square plus y square. This will get cancelled with that. So we are left with xy over square root x square plus y square. So now we have the coefficient of ax cap, ay cap and az cap. Therefore we can put that in equation number 1. So we get ax cap and then the coefficient x y z minus 3xy over square root x square plus y square plus a y cap y square z plus 3x square over square root x square plus y square plus a z cap x y over square root x square plus y square. So, with this, let me stop here. See you in the next class. Thank you.